Attention, master decoders! You cracked the case of algebraic expressions, but are you ready for the ultimate upgrade? Welcome to the world of simple equations. If expressions are secret codes, equations are the actual locks we need to open. Today, we're not just writing the code, we're finding the one specific key, the number, that makes everything perfectly balanced. It's like a high-stakes puzzle where only one piece fits. Grab your detective gear, because Focus 1, Knowing Equations, starts now. Let's start with a warm-up on slide 2. Look at these boxes. Something plus 2 is 5. We all know it's 3, right? And something minus 4 is 6. That's 10. But in the world of professional detective work, we don't just use empty boxes. Boxes are for kittens. Spies use letters. The logic is the same. Find the number that makes the left side equal to the right side. It's all about balance. If the scale isn't level, the case isn't closed. Remember our stationery shopkeeper? He's back. He's raising prices by $5 again. Original price is X, new price is X plus 5. That's just an expression. But look at slide 4. If we know the new price is $15, we can write X plus 5 equals 15. That equals sign is the most powerful symbol in your kit. It turns our expression into an equation. Now the mission changes from writing a rule to finding the X. What number plus 5 is 15? 10. Our mystery price is solved. X is 10. Boom. Case closed. Now, the discount sweater on slide 5. Price C minus 50 is the expression. On slide 6, we find out the new price is $140. Our equation, C minus 50 equals 140. Think about it. What number gives you 140 if you take 50 away from it? You have to give that 50 back to find the original. 140 plus 50 is 190, so C is 190. You see the pattern? Equations tell us the end of the story, and we work backward like detectives to find the beginning. Hungry for more? Slide 8. $7 per topping. Ye toppings. Total cost $28. Equation? 7y equals 28. What times 7 is 28? 4. 4 toppings for Tony. And slide 10, teddy bear cloth. M pieces divided by 4 portions equals 6 pieces per portion. Equation? M over 4 equals 6. If we split M 4 ways and get 6, the original must be 4 times 6, which is 24. Notice how multiplication and division are just mirror images of each other? It's like looking in a math mirror. Let's get official on slide 11. An equation is a mathematical statement showing two things are equal, and it must have an unknown. If there's no unknown, it's just a boring fact. If there's no equal sign, it's just an expression. An equation is like a locked door with a specific key. X plus 5 is 15. C minus 50 is 140. These are all equations. They are the language of balance. If the left side doesn't match the right side, the universe starts to wobble. Just kidding, but your math teacher might. How do we find the key? Look at slide 12. Equation. A plus 6 equals 10. Let's try A equals 2. 2 plus 6 is 8, not 10. Different. Try A equals 3 on slide 13. 3 plus 6 is 9. Almost. Finally, on slide 14, we try A equals 4. 4 plus 6 is 10. It matches. Slide 15 gives us the formal name. The number that makes both sides equal is called the solution. Think of it as the unlock code. When you find the solution, the puzzle is solved and the detective gets a gold star. Time for a quick roundup. On slide 16, which are equations? T minus 5 equals 12? Yes, equals sign plus unknown. 8 times 7 equals 56? No, that's just a true fact, but it's missing the mystery unknown. On slide 17, finding solutions? For U minus 8 equals 19, the key is 27. For F over 7 equals 14, the key is 98. You're spotting the keys and unlocking the doors like a pro agent. Focus 1 is officially in the bag. Mission 1, success. You now know exactly what an equation is and how to find its solution using your brain and a little bit of trial and error. But real detectives don't just guess numbers, they have a system. In part 2, we're going to learn the balanced scale method to solve equations even faster. It's going to be epic. Go grab a glass of water, calculate the volume later, and I'll see you in the next case. Keep those brains sharp, detectives. Welcome back to the lab, agents. You know what an equation is, but now I'm going to show you the ultimate secret weapon for solving them, the balance scale. Think of an equation like a perfectly level scale. If you add a heavy rock to one side, it tips over, unless you add the same rock to the other side. Today, we're going to use this do the same to both sides rule to uncover our mystery letters. It's fair, it's balanced, and it's the only way to keep the math universe from collapsing. Let's check out slide 18. Slide 18 is our mission briefing. If we have to add or take away something from our equation, we must do it to both sides. If I give the left side a cookie, I have to give the right side a cookie. If I take away a heavy boot from the right, I take it from the left too. This is the golden rule of balance. Without it, our detective work is just guesswork. Let's see it in action with a real mystery on slide 20. On slide 20, we have y plus 4 equals 9. The plus 4 is blocking our mystery IY. To get rid of it, we do the opposite. We subtract 4 from both sides. 4 minus 4 is 0, y is finally free, and 9 minus 4 is 5, so y must be 5. Check out slide 22 for 5 plus h equals 12. We subtract 5 from both sides to find h is 7. Slide 24 shows 16 equals p plus 7. Subtract 7 from both sides. P is 9. The way of thinking is simple. Addition's enemy is subtraction. Use it to isolate your mystery person. But what if our mystery letter is being robbed? On slide 28, we have x minus 3 equals 5. Someone took 3 away from x. To rescue it, we give those 3 back to both sides. X minus 3 plus 3 is just x, and 5 plus 3 is 8. X is 8. Slide 30. R minus 7 equals 9. Add 7 to both sides. R is 16. Slide 32. 14 equals E minus 6. Add 6 to both sides. E is 20. The way of thinking here, if you see a minus, you use a plus. It's like a math rescue mission. Give back what was taken, and the mystery is solved. Now for the squish. On slide 36, we have 3b equals 6. That means 3 times b. They are squished together. To separate them, we use the opposite of multiplication, division. We divide both sides by 3. 3b divided by 3 is just b. 6 divided by 3 is 2. So b is 2. Slide 38, 5k equals 30. Divide both sides by 5, k is 6. Slide 40, 6l equals 24. Divide both sides by 6, L is 4. Multiplication is a strong glue, but division is the super solvent that dissolves it. Always keep the balance by dividing both sides by the same leader number. Wait, detectives! Before you go, slide 23 has a vital tip. Always check your answer. Once you find your solution key, put it back into the lock to see if it actually turns. If you think H is 7, check. Is 5 plus 7 really 12? Yes. Then your solution is correct. If the scale doesn't balance, your key is a fake. You've just learned how to defeat addition, subtraction, and multiplication locks. You're becoming the most feared math agents in the city. In part 3, we'll tackle division locks and some real head scratchers. See you in the next briefing. Stay balanced. Agents, we have a situation. You've mastered addition, subtraction, and multiplication locks, but the villains have upgraded their security. They are now using division locks. They've split our mystery numbers into tiny pieces, and we need to put them back together. In part 3, the division dilemma, we're going to learn the final move in our balance scale technique, the multiplication rescue. But first, a quick brain teaser to make sure your detective minds are sharp. Let's look at slide 43. Slide 43 is a classic spy code. Green square is 3, red circle is 5, purple rectangle is 8, and square rectangle is 19. Wait, 3 plus 8 plus 8 is 19. So the code is addition. Now what is circle, circle, square, rectangle? That's 5 plus 5 plus 3 plus 8. 5 and 5 is 10, plus 3 is 13, plus 8 is 21. The answer is D. And for the triangle mystery below, if triangle times 5 is greater than 30, the triangle must be greater than 6. Because 6 times 5 is exactly 30. So the answer is C. Logic circuits activated? Good. Let's save some fractions. Here it is on slide 44. G divided by 3 equals 4. Our poor mystery G has been sliced into 3 pieces. To make G whole again, we need to do the opposite of dividing by 3. What's the opposite? Multiplying by 3. But remember the golden rule. What we do to the left, we must do to the right. So, we multiply both sides by 3. The 3's on the left cancel out, poof! And on the right, 4 times 3 becomes 12. G is 12. We put it back together. Slide 45 confirms it. Multiplying both sides keeps the scale perfectly balanced. You're a math surgeon. Let's run some more rescue missions. Slide 46. D divided by 4 equals 5. We multiply both sides by 4. D is freed, and 5 times 4 is 20. D equals 20. Checking, 20 divided by 4 is 5. It works! Slide 48. 3 equals F divided by 5. Don't let the order fool you. We still multiply both sides by 5. 3 times 5 is 15, so F is 15. And slide 49, Q divided by 6 equals 7. Multiply by 6, Q is 42. See the pattern? If it's divided, you multiply. It's the anti-slice maneuver. Time to prove your skills in the consolidation zone. Slide 50, C over 9 equals 8. Multiply both sides by 9. 8 times 9 is 72, so C is 72. Slide 51, 10 equals H over 12. Multiply both sides by 12. 10 times 12 is 1 to 20, so H is 120. You are flying through these. You now have the power to solve any simple equation. Plus, minus, times, or divide. You have the complete set of keys. Mission accomplished. You have officially conquered Focus 2, solving equations. You can balance any scale and find any mystery number. But detectives, the world is full of messy problems that don't look like neat little equations yet. In Part 4, we're entering Focus 3, Solving Problems. We're going to take real-world stories and turn them into equations ourselves. It's the ultimate test of a math detective. Rest up, sharpen your pencils, and I'll see you for the next big investigation. Detective Agency, over and out!